Greetings, my beloved scholars. Hope you are good today. I'm Mr. Okafor PC, online physics teacher. Okay, today we'll be testing our knowledge on equations of motion with calculation question. Okay, let's see from the board. We have a question on the board. When you look at this question, you understand that this question is centered on equations of motion. It's motion related. Okay, let's go to the question in details. A motorcycle starting from rest is uniformly accelerated. A motorcycle starting from rest from a parked point is uniformly accelerated such that its velocity in 10 seconds, such that its speed in 10 seconds is 72 km per hour. 72 km per hour is the speed of velocity in 10 seconds. What is its acceleration? What is the motorcycle's acceleration? Okay, let me demystify this question. It's just like somebody going to the park or to a park point to move a motorcycle. Then the person moves the motorcycle at a certain speed in a certain time. So the starting speed of the motorcycle is 0 meter per second, the initial speed. Then the final speed is 72 km per hour. There are two speeds there. In equations of motion, be conscious of the word rest. Rest, because in your equations of motion, the rest position is indicated. Okay, the next thing we do now is to put all equations of motion on the board. Let's get all the formulas on the board to know the best one that suits our equation. Okay, solution. First of all, give yourself that confidence that you can do it. Put solution. Okay, then let's see our four equations. This is how to go. Anytime you see any equation related to equations of motion, get your four equations. Okay, the first one says V is equal to U plus AT. Our first equation of motion. The second goes this way. V squared is equal to U squared plus 2AX. This is our second equation. Then our third equation, S is equal to UT plus half AT squared. Then lastly, S is equal to U plus V all over 2 times T. Four equations of motion. Then the next step is this. Go back to your equation and bring out your parameters. Let's see those quantities that were specified in our equation. We'll go back. A motorcycle starting from rest. Circle it. Rest, indicate it. Rest means initial speed. 0 meter per second. The starting speed was 0 meter per second. That's the rest position. It's uniformly accelerated. The acceleration was uniform. It didn't change. The increasing speed was maintained. In every 1 second, the same speed was maintained. That's what I mean by uniform acceleration. So the speed was maintained in every time interval. Okay. Such that its velocity in 10 seconds. Something has been indicated here. Time. T is equal to 10 seconds. 10 seconds. Recall, such that its velocity in 10 seconds is. This is the velocity we are looking for, the final velocity. V is equal to 72 kilometers per hour. 72 kilometers per hour. Okay, then I want you to observe something about our final speed. The unit is kilometer per hour, whereas the unit in the initial speed is meter per second. We have to reconcile that. Kilometer and meter are two different units of one physical quantity, which is length or distance. So we convert kilometer to meter. Likewise, seconds and hour. We cannot have different units for a particular quantity. Seconds and hour are units of measurement for time. So we'll go for seconds. We'll convert hour to seconds. That is why in our previous videos we started with conversion. Because you can never do well in physics without understanding the nitty-gritty in conversions. So let's convert kilometer per hour to meter per second. A very simple conversion. Observe. Okay. Just take it natural. What's the number there? 72. Arrange these units better. It simply means kilometer per hour. That's what we said. Kilometer per hour. Okay. Then go natural. Then the V will now be. Okay. 72. Put it down again. Times. The word kilo has mathematical equivalence. Kilo stands for 1,000. 1 kilo. 1K. 1,000. Okay. So 1,000, 1,000. Then drop the meter. Meter will just drop. Meter over. Then you ask yourself, what is the equivalent of hour to seconds? Equivalent of hour to seconds. So recall, 60 seconds make 1 minute. 60 minutes make 1 hour. Then follow that observation. You notice that 60 times 60 of 60 times 60 will now give you an hour. 60 seconds, 1 minute. 60 minutes, 1 hour. Therefore, 60 times 60 will give you 1 hour. That means 3,600 seconds is 1 hour. 3,600 seconds is the same thing as 1 hour. Anywhere I have an hour, it means 1 hour. Therefore, I can also put 3,600 seconds in place of that 1 hour. So 3,600 seconds. Conversion done. The final unit now is now meter per second. You can now see that I'm taking a final velocity to meter per second. Meter per second. Very simple. Conversion. Very sweet. Okay. Then let's now do the arithmetics. Simple conversions. Yeah. When you do your arithmetics, you observe that at the end of the day, you'll be getting 20 meters per second. That's our final speed. When you do the mathematics, you'll be getting 20 meters per second. So our initial speed is 0 meters per second, whereas our final speed is 20 meters per second. So we'll continue. Then the question says again, what is its acceleration? A, question mark. A, question mark. Then observe the parameters, go back to equations of motion to know the best equation that suits the parameter in the equation. Okay, let's observe. We have U, we have T, we have V, we have A. You can observe in the parameters available here, there is no distance. So we'll go back to our equations of motion. Anywhere there is distance, we cancel. That formula cannot help us. Any formula that involves distance can't help us in this equation. Okay, let's go to equations of motion. There is distance here. This formula is out. Out, out. So the only equation that survives the test of our equation is the first one. And we'll apply it. Okay. Okay, let's solve using the first equation. What's my V? V is 20 meters per second in the actual units. What's my U in the parameter? 0 meters per second. What's A? A is what I'm looking for, the unknown variable. Maintain it. A times, what is T? T is 10 seconds in its actual units. 10. Therefore, 20 equal to 0 is nothing. So A times 10, the number comes first, 10A. Okay, then when you have a number and an unknown, you make the unknown the subject of the formula by dividing both sides by the coefficient of the unknown. So we divide both sides by 10. Finally, our answer is 2. 20 divided by 10, 0 cancels 0. 2 over 1, which is 2. The SI unit of acceleration is meter per second square, or 2 meters second raised to the power minus 2. So we've gotten our acceleration. Then we'll go back to our options. Let's see if our answer is in the option. Option D. Option D. 2 meters per second square. Then let me now explain. C. Please try also to understand the idea behind the calculation we've done. Recall, the motorcycle was parked somewhere. Then all of a sudden it started moving at speed of 20 meters per second in 10 seconds. Then we've now gotten the acceleration. The increasing speed that was maintained is now 2 meters per second square. See what it means? It means that in every 1 second, the motorcycle was increasing its speed by 2. In every 1 second, 2 meters per second. 2 seconds, 4 meters per second. 3 seconds, 6 meters per second. In every 1 second, it was increasing the speed by 2 meters per second. In every 1 second, the speed was increasing by 2 meters per second. Let me give you a clearer instance of what I'm saying. Okay, let's presume I'm a teller. Why you need to know your physics calculation? Science allows you to predict what happens. Let's presume I'm a teller, and there is a customer. I've promised that he will pick his slots by so time. Okay, then I have another work that will pay me more. Then I begin to do the work. Then all of a sudden I now recall that a certain customer will come for a particular way. So if I am able to know the customer's uniform acceleration, so if I can tell how fast the customer is coming, I can also tell myself how fast I need to lock the shop and disappear within that time. I don't know if you get my point. If you know how fast something is coming, in every 1 second, this customer is coming in with speed of 2 meters per second. In every 1 second, this customer is coming with speed of 2 meters per second. If I can tell the distance or the time it will take this customer to come, I can also know that within this so time and with this speed, this customer is coming here. So you can know the best time to avoid that customer. But pardon me, this is a negative example, but just to portray the idea that you can predict people's motion. And that's what equations of motion does for us. It gives us idea of how motions occur. Then if you want to see this in real life application where it saves a nation, you talk of military. In military, they don't joke with these calculations. This is how you can tell how fast a missile is coming and intercept the missile. So physics is spice of any great nation. Please, my scholars, stay tuned as we go on with physics theories, calculations, and practicals. Thank you. Please do subscribe.